All right, it's the first class back after our 2019 snowpocalypse. It is February 1st, 2019. Let's review what we did before we went on our hiatus. So the first thing that you might remember from before we went on that 4-day little snow day break would be absolute value. Now remember, absolute value is asking the question, how far is a number away from zero? So for instance, the absolute value, which is this symbol right here, that's the absolute value symbol. It's kind of like parentheses except straight lines, of a number, let's say, how about -2? Really what it's asking is, how far is -2, this number right here, from 0? Well, -2 is 2 away from 0. That's how far it is. Remember, distance is always positive. So absolute value, what it does is it takes the number inside the absolute value and spits it out positive. If I were to ask the question of, hey, what's the absolute value of +2? Well, remember, what it's asking is, how far is, this time, 2, how far is 2 away from 0? Well, it turns out 2 is just as far from 0 as -2 is from 0. They're both 2 apart. So it turns out absolute value takes negative numbers and makes them positive, and positive numbers, it keeps them the same. For a question like the absolute value of 0, we'd be asking how far is 0 away from 0, which you know is 0 distance. Now you don't need to bust out a number line every time, like I said. Knowing that absolute value takes negatives and makes them positive, positives keeps them the same, and zeros keeps them the same, you'll be fine. At the end of the day, everything that pops out is, for lack of a better term, it's always going to pop out positive. Obviously, 0 is neutral, but everything always pops out positive when everything is said and done with absolute value. The way I've heard it described is it's like a washing machine. You put in your dirty clothes, your negative numbers, and the washing machine cleans them, right? It comes out positive. If you were to put clean clothes in a washing machine, well, they'd still pop out clean, right? And same thing in 0. If you put nothing in a washing machine, what pops out? Nothing. Right? So that's absolute value. Let's talk about what that would look like as a graph. So if we had a function f of x equals the absolute value of x, okay? So if we had this, if you didn't know what was going to happen, since this is a review, you probably do, but if you didn't know, you could make a little chart like you can for any type of equation, and you can try and see what happens. So let's pick some numbers to plug in for x and see what pops out for f of x. So let's pick -2, -1, 0, 1, and 2. This is a good representation of positive, negatives, and neutrals. And it should give us a pretty good picture of what's going on. So what we're doing is we're taking this number right here, x equals -2, and we're going to plug it in here. So f of -2, taking this guy, plugged in here, we switch them out for x. Well, we learned earlier that the absolute value of -2 is 2, which is true. F of -1 is when we plug in -1 for x. So instead of -2, now we're plugging in -1. And what do we get? Well, the absolute value of -1 is 1. F of 0, well, it's asking the absolute value of 0, which we already said earlier is 0, right? So 0. And the absolute value of 1 and 2, well, we know that 2 is 2. So 1 is going to be 1 as well. So now we're going to take these, because these are coordinates. They're points. And we're going to plot those points and see what the graph looks like. So when we graph this, we have -2, 2. That's here. And we have -1, 1 there. 0, 0. 1, 1, and 2, 2. And if you see, these dots form a V going in both directions. So this V points upwards, and this point right here, the bottom of this V, is called the vertex. So that part is called the vertex. And the vertex for this one is at 0, 0. It's actually the point where it turns around, right? We're heading down 2, 2, 1, 1, 0, 0. You'd think the next one would be -1, -1 or something like that, which would actually put us over here. But no, it's not. It continues going down. Instead of continuing going down, it actually heads back up. So this is the turning point for our V. and we call that the vertex. You'll see 2, 1, 0, and then it starts heading back up again. So that's the basic graph of f of x equals absolute value of x. Now, if we were to take this concept and expand it a little bit, we can make an all-encompassing formula for any type of absolute value equation. So normally we have absolute value of x, right? Well, we can add on a couple things here, like a number in front to multiply it by. We're going to call this a because it's similar to slope, but not quite the same. So we're not going to use m. We're going to call it a, and this is our slope. It's going to tell how steep that v is. So when we have our v, the bigger that number is, the steeper it gets. Whereas the smaller that number is, the closer it is to 0, the wider it gets. So you might imagine if we have a fraction like a half, a is a half, it'll be very, very wide, versus a being 10, it would be very, very steep. If a is 0, it actually turns into a flat line and gets rid of our v because it's kind of like our slope, and a slope of 0 is just a horizontal line. As soon as that starts going negative, well, if this is really big positive, and this is smaller, smaller, and smaller positive, and then here's 0, you can predict what's going to happen if we go negative. It's going to start heading downwards. So it's going to start opening down this way. So a number that's really close to 0 and negative is going to be really wide, like a negative fraction. And a number like negative 10 is going to make it really, really steep, heading downwards. And again, this point right here at the top would be our vertex. Same thing here. It would be our vertex down here. So a is our slope. It tells us how steep it is and what direction it opens up into. And we're going to use it just like slope from our point slope form. And then over here, we have a number inside that's being subtracted. And we're going to call this number h, just like we did for point slope form. We could also have a number on the outside, right? We could do multiplication and subtract a number before doing absolute value. We could also do something after absolute value, like adding a number. And we're going to call that number k. And very similar to h and k from point slope form, h and k is going to be our vertex for this. So it's going to be that point where the v comes together, right? So h is going to be the coordinate here, and k is going to be the y value of that coordinate. Now it's important to remember that we don't just take these letters for granted, right? Whatever number's here does not just go here. We have to change this number. So if that was a minus 5 here, a positive 5 would go there. If that was a negative 5 here, I'm sorry, if it was a plus 5 here, then a negative 5 would go there. So the sign changes. See how it's minus up here, minus h, and down here it's positive h? Up here we have positive k, and look, down here we also have positive k, so this one stays. Again, minus h turns into positive h. If it was positive up here, it would be minus down here. They flip, right? Here, positive k stays positive k. Negative k would be negative as well. So this one's keep the sign, this one changes the sign. And that's going to be your vertex. All right, so let's use this to graph something really easily without having to, plug in a bunch of numbers like we did here, right? That was kind of a pain, lots of room for error. Let's use this information to make a quick sketch of our graph. So here's an example, right? Here's an example. So f of x, I'm going to tell you it equals, how about negative 2 absolute value of x, and then we'll do plus 4 minus 5. All right, so here's our example. So from here, we can pull out some valuable information. We've got our vertex, right? Very important point. And it's going to be this guy, but again, we have to change it. See how this guy's negative and turns positive? Well, this guy's positive, so we need to make him negative for our vertex. And then we've got this part, which is staying the same, right? If it's positive, it's positive. If it's negative, like it is here, it must be negative. So there's our vertex. Our vertex is going to be at negative 4, comma negative 5. So let's graph that. Plot that dot. So at negative 4, comma negative 5 should be our vertex. So 1, 2, 3, 4. Negative 5 is 1, 2, 3, 4, 5. So that vertex is going to be here. Negative 4, negative 5. Right there. That's our vertex. Alrighty. So that's the vertex. Now we know from our slope here, our a value in front of here, -2, our slope is going to be opening downwards, right? It's going to be down 2 over 1. We write that as a fraction. So from our vertex, we go down 2 over 1 this way. So our next dot goes there, and our next dot goes here. So we've got our 2 dots on the left and the right side of our vertex, and now we can make our V. That's it. There's our graph. So we take these 2 numbers and we plug them into our vertex. So we can do this. This number changes, this number doesn't. And then we use the slope to find 2 more points on the left and right side of the dot and draw our lines. If this was a +2, we would have gone up 2 over 1, and you can see how that would make it open up as a V instead of down. Cool. So let's do a little bit more with this example right here, actually. So if I were to ask, hey, I know what f of x is, it's all this. But what would f of, let's do -4, or how about, let's do -3. F of -3, what would that be? So really what I'm asking here is, if instead of x I had -3 here, what would pop out? What would all this equal? So we can do this algebraically, which we will. And the way we do this is we write the same equation, except now we're going to write f of -3 instead of f of x. And that's going to equal -2 absolute value of everything the same, except instead of x, we're going to have -3. We switched them out. Now we're here. So now we do math. We have -2 times whatever the absolute value of that is, -5. Well, -3 plus 4, let's do that first. That's going to be 1. And then we do absolute value of 1, which we already know is going to be 1, because absolute value of a positive number is just that positive number. And I wrap it in parentheses so that we remember that this is multiplication. -2 times 1 is -2. And then we do -2 minus 5, and we get -7. So we plugged in -3, and we got -7. F of -3 equals -7. So that's the answer for that. F of -3 is -7. Now, there's an easier way to do this. If you have a graph handy, which we do, we made our graph. If you look, we know what f of -3 is from our graph. So x is supposed to be -3, right? That's what we plugged in for x. So here's -3 on the x-axis, right here. So on our graph, what happens at -3? Well, this happens right here. And if you extend this out, you'll notice that at -3, this coordinate right here is at -7. So we can tell from the graph what's going on. If I were to ask what f of -5 was, well, you'd go over to -5 on the graph, which is right here, -5, and you'd notice that, hey, look, that's also -7. See how this dot is also at -7? So f of -5 is also -7. If I were to ask about f of -4, the number in between -3 and -5, well, -4 is right here, right? Right there. And at -4, we're here, which is at -5. 1, 2, 3, 4, 5. So f of -4 is -5. Now again, if your graph doesn't have that, like if I ask for f of -12, that's way over here. We don't have a point that we can see. There's going to be one. We just don't know where it is. It might be easier just to plug that number in and see what happens. So let's try f of 0. Now 0's here, and again there should be a point, but it's way down here. We don't know where it'll be. Let's just plug it in and see what happens. Again, we're going to solve this algebraically. So I take this, and I want to know what f of 0 is. So that's going to be -2 times the absolute value of 0 plus 4, closed absolute value, minus 5. So now I do 0 plus 4 on the inside here, and that's 4. And I ask myself, what's the absolute value of 4? Well, it's 4. And I wrap it in parentheses to remind me that I still need to multiply negative 2 and 4 together. Negative 2 times 4 is negative 8. And that minus 5 from earlier makes negative 13. So f of 0 equals negative 13. That's way down there, negative 13. 0 goes all the way down here, way below the camera. I can also write that as a coordinate, right? 0 comma negative 13. So those are absolute value functions. That's how you graph them. I'm going to do one more example with a fraction here. So if you're given this, f of x equals 2/3 absolute value of x plus 1 minus 2. Well, to graph it, just what we did before. This is going to be our vertex, which we know we changed the first one, so minus 1, and keep the second, minus 2. And when we plot this, negative 1, negative 2 is here. That's our vertex. Okay? And then we use our slope to find 2 more points on the left or the right to draw our lines. So slope here is 2 over 3. So it's up 2 over 3. It's going to open upwards, up 2 over 1, 2, 3. So there's our next point. And we need the other side of this v, so up 2 over 1, 2, 3 this way. And we draw our lines. So fraction's not so scary. If we wanted to know what, let's say they said, hey, by the way, using the same equation, what would f of 2 be? Well, we could check here and see that 2 would be 0. At 2, x2, right? That's our x value at 2. Our y value is 0. We could also check that algebraically. F of 2 equals 2/3 absolute value of 2 plus 1 minus 2. I just plugged in 2 for x. So now I do math. 2 plus 1 is 3 in the absolute value. Absolute value of 3 is 3. And then we do times. 3 times 2, then divided by 3. Or you could do 3 divided by 3, and then times 2. We can either times by the top and then divide by the bottom, or we can divide first and times second. I'm going to divide first. 3 divided by 3 is 1. Then we times by the top and get 2. So that becomes 2. We still have to subtract the 2 from here. So now we do 2 minus 2 and get 0. So f of 2 is 0. If I were to ask you what f of negative 1 was, you could plug it in and do the same thing. Or you could check, hey look, here's negative 1. Should be negative 2 for the answer. Last thing before I go, with absolute value. What if they give you the graph and want you to make the equation? Before I was giving you the equation and you made the graph. Well, this isn't that bad. Let's pick this and there we go. So there's my graph. And I can see that it's absolute value because I have a v. And we're going to write the equation. So f of x equals whatever it is. So first we need the vertex, which is this guy right here. That's our vertex. Looks like the vertex is at 2, 4. Okay. So the vertex is at 2, 4. That means when we write our equation, leave a space for the a. We haven't done our slope yet. It's going to be x minus 2. Remember, we changed the sign here, right? If it's negative here, it's positive there. So if that's positive, this must be negative. And we keep the sign here, plus 4. Now to get the slope, the angle that's coming off this vertex. Well, if you look carefully, between these 2 points, we go down 1, 2, 3, 4, 5, 6. So we went down 6, and we went over 3. So our a value, or our slope, is negative 6 over 3. And That makes sense because a negative means it opens downwards, and this does. Now we can simplify this to negative 2. So that negative 2 goes in front of here. And that's it. That's the equation. So there's a little refresher on absolute value, graphing, and taking the graph and making the equation. And the next video for review, I'll review over the piecewise functions.